Good day, class. Our topic for today is all about sequence and series. Now, let's have our objective. Our objectives are be able to solve both arithmetic and geometric sequence and series, be able to keenly observe and investigate patterns. Now, let's have our definition. First, we have sequence. Sequence is an enumerated collection of objects in which repetitions are allowed and order matters. Like a set, it contains members, also called elements or terms. It is also a function whose domain is a set of positive integers. Okay. Now, let's have an example. So, example of sequence, we have here a set of 3, 5, 7, 9, and so on and so forth. So, as you can see here, the first number, we call it the first term. The second number is the second term, third, and fourth. So, it's separated by a comma. As you can see, we have 3 dots there. So, the 3 dots, we call it means goes on forever, infinite, or continue. Okay, so term, element, or member means or it has the same meaning. Okay, now let's have another example. Okay, example 1.1. As you can see, we have a set of 1, 2, 3, and 4, and then so on and so forth. So we called it an infinite sequence. While the other one, we have the set of 1, 3, 5, and 7. It doesn't have 3 dots. We called it finite sequence. So it has a limit. Okay. Next, we have 4, 3, 2, 1. So this set, we call it backward sets. So it's also a sequence. Next, we have a set of alphabet. We have A, B, C, D, and E. So it is also a sequence. Next, we have the set of 0, 1, 0, 1. It is an infinite sequence and it also an alternating set. Last one, we have 1, 2, 4, 8, and 16, and so on and so forth. So it is also an infinite sequence, but in every term, it doubles. So these are an examples of a sequence. So now let's discuss the two types of sequence. First, we have arithmetic sequence. So arithmetic sequence has a constant difference between each term. Once you add or subtract on each term, the answer is equal. So let's have the formula for our arithmetic sequence. So for the formula, we have an is equal to a sub 1 plus d times the quantity of n minus 1, where an is equal to the nth term. The a sub 1 means the first term. The d is the common difference of the terms, and letter n is the number of terms. So we're going to use this formula to solve a set of sequence. So let's have an example. We have example number 1. So we have set of 1, 4, 7, 10, and 13, so on and so forth. So we need to find the seventh term of this set. As you can see, we only have 5 terms here. So we need to find the seventh term. We're going to use the formula. So the formula is an is equal to a sub 1 plus d is equal to d times n minus 1. So now, let's substitute the value. So we have the a sub 1. So the a sub 1, the value of a sub 1 is the first term. So our first term here is 1. Okay, next. D. What is the common difference? So the common difference of our term here is 3. Okay, next we have the value of your n. So we're number of terms. So here we're searching for the 7 terms. So we're going to put 7 there. Okay, so now we have 1 plus 3 multiplied with the quantity of 7 minus 1. So let's have the rule of m dash. So 7 minus 1 is 6. Then 3 times 6 is 18 plus 1. So the answer is 19. So the value of 7th term on this set is 19. Did you follow? Okay, so now let's have another example. Example number 2. So example number 2, we have set of 3, 7, 11, and 15, so on and so forth. So we need to find the 10th term of this sequence. So first, by using our formula. So first, let's substitute the value. So let's rewrite an is equal to a sub 1 is the first term. So our first term is 3 plus d. So d is the common difference of our terms. So the common difference of our terms are 4. Next, open parenthesis, the value of your n. So n is the number of terms. So number of terms we're going to find is 10. So we put it here, minus 1. Then, let's simplify. Let's copy an. Okay. So 3 plus 4, open parenthesis, 10 minus 1 is 9. Next, copy an. So 3 plus 4 times 9 is equal to 36. Then, let's add. So an is equal to 39. So the value of your 10th term is 39. Did you get it? Okay, very good. So now let's have the other sequence. We called it geometric sequence. Okay, now let's have geometric sequence. So geometric sequence has a constant ratio, or we call it the multiplier, between each term. Okay? So, the difference between the arithmetic and geometric sequence is arithmetic, once you add or subtract to each term, it is equal. While in geometric sequence, once you multiply or divide each term, it's also an equal. So that's it, or that is the difference between the two. Now, let's have the formula for the geometric sequence. So for geometric sequence, we have n is equal to a sub 1 times r raised to n minus 1, where an is the nth term, a sub 1 is equal to first term, r is the common ratio or the common multiplier, and n is the number of terms. So we're going to use this this formula to solve for the geometric sequence of a set. So now let's have an example. Let's have example number 1. So we have 2, 4, 8, 16, 32, and so on and so forth. We need to find the 10th term. So as you can see here in this example, the multiplier is 2. When you multiply the first term, you will get by 2, you will get 4. When you multiply the second term by 2, you will get 8. Okay, so and so forth. Okay, so our common multiplier here is 2, or the common ratio is 2. Now we're going to find the 10th term. So using by the formula, okay, so let's substitute the value. So first we have a sub 1, which is our first term, which is 2. The r, or the value of r is, the common ratio is 2 raised to what what term, which is 10. So 10 minus 1. So now let's simplify. So 2 times 2 raised to 9. Okay, so first 2 raised to 9 is equal to 512. Then multiplied it by 2, we get 10, or 1024. So the value of the 10th term is 1024. Did you follow? Okay, so let's have another example. So let's have example number 2. So we have 3, 6, 12, and 48. Find the 20th term. Okay, so we're going to find the 20th term. First, let's have our solution. Now, let's use the formula. So, our formula is an is equal to a sub 1, multiply it by the ratio, raised to the number of terms minus 1. So, let's substitute the value. So, our a sub 1 is 3. The common ratio is 2. the number of terms is 20 minus 1. Now, let's simplify. So, let's copy AN. So, 3. So, 20 minus 1 is 19. So, 2 raised to 19. Let's copy. 3. So, 2 raised to 19 is equal to 524,288. So it's 524,288. Multiply it by 3. So the answer is 1,572,864. So this is our 20th term. Did you follow? Now, let's talk about the next topic. We called it series. So, series is the sum of the various numbers or elements of a sequence. So, the difference between sequence and series, so sequence is a collection of objects or numbers or orders, letters, while series is the sum. So we're going to total the numbers of the elements or the sequence. Okay. So now let's have the formulas. So we have the arithmetic series. For the arithmetic series, we have Sn is equal to n over 2 times a sub 1 plus an, where Sn is the sum of the terms. A sub 1 is the first term, and n is the number of the terms. So we're going to use this formula to total the sequence. Okay. So now let's have the example. So we have example number 1. We have here 1, 4, 7, 10, and 13. So we're going to find the total of this sequence. So using by the formula, we have Sn is equal to n over 2 times a sub 1 plus 8n. So we substitute the value. So for n is the number of terms. So let's count. So we have 1, 2, 3. So the terms here is 5. So we have 5. Then a sub 1. So the value of your a sub 1 or your first term is 1. And the value of your n is, or the n term or the last term is 13. So we have 5 over 2 times 1 plus 13. Let's simplify. So 1 plus 13 is equal to 14. Then 5 over 2 or 5 divided by 2 is 2.5. Then let's multiply. So 2.5 times 14 is equal to 35. So the total of this sequence is 35. If you're going to compute it manually, you will get the same answer. So, did you follow? So, now let's have another example. Example number 2. So, let's have example number 2. We have 3, 7, 11, 15, and 139. So first, we need to find the total. So first, we need to find what is the position of what term is 139. Now we're going to use the arithmetic or the formula for the arithmetic sequence to solve this sequence. So let's solve. So now this is the formula for the arithmetic sequence. We're going to first we're going to substitute the value. We have the a sub 1, which is 3 plus the common difference. So the common difference here is 4. It's 4. Then the number of terms we don't know, so we put n minus 1. The a sub n is the last term. So 139, or the value of the last term here. Now let's simplify. So 139 is equal to 3 plus distribution. So 4n minus 4. So 4 times n and 4 times negative 1. We have 4n and negative 4. Now, let's simplify. So 139 is equal to 3. Positive 3 minus 4 is equal to negative 1 plus 4n. Then, transpose a negative 1 to the other side. So we have 139 plus 1 is equal to 4n. So now, let's simplify. We have 140 is equal to 4n. Okay. Now, divide both sides by 4 so that we can find what is the value, or what is the term for what term is 139. So cancel is equal to n. So 140 divided by 4 is 35. So that 139 now is in 35th term. So we're going to use this one to find the total value of this sequence. So now we already know what is the term of 139. So let's now solve for the total. So substitute, we have the n, which is 35 over 2 times the value of a sub 1, which is 3, plus the last term, which is 139. Then simplify. So we have 35 divided by 2 is equal to 17.5. Then 3 plus 139 is equal to 142. Now, the total is 17.5 times 142 is equal to 2,485. So this is the total of this sequence. Did you follow? So now let's talk about geometric series. So we have here the formula. We have Sn is equal to a sub 1 times 1 minus r raised to n over 1 minus r, where Sn is equal to the sum of the all terms, and r is the common ratio, n is the number of terms. And again, a sub 1 is our first term. So now let's have an example. Okay, so we have here a sequence of 3, 15, 75, and 375. So we need to find the total of this sequence by using the formula Sn is equal to a sub 1 times 1 minus r raised to n over 1 minus r. So first, we need to substitute the value. So for the value of our a sub 1, which is 3, times 1 minus the common ratio. So what is the number? We're going to multiply by 3 to get 15. So it is 5. So 3 times 5 is 15. So 15 times 5 is 75. 75 times 5 is 375. So our common ratio now here in this sequence is 5. Then raised to the number of terms. So here in our sequence we have 4 terms. So we need to raise it by 4. Now, over 1 minus r, or the common ratio, which is 5. Now, let's proceed for, let's solve for this one. Now, so 5 raised to the 4th power is negative 6, 625. So 1 minus 625 is equal to negative 624. So times 3. So 3 times negative 624, we're going to get negative 1,872. Then 1 minus 5 is equal to negative 4. So the answer 1,872 divided by negative 4. Since they have the same sign, which is negative, so negative divided by negative, it will become positive. So 1,872 divided by 4 is 468. So the total of this sequence, this 4-term sequence, is 468. Okay? So by using this formula, you don't need to manually calculating or calculated the sequence. Okay? So that's all for today. Thank you.